The 7.65 gigawatts workaround. Amazon is actively pouring concrete on a 7.65 gigawatt natural gas power plant in West Texas. The facility, named GW Ranch, will run 35 gas turbines to power a massive new AI data center entirely off the grid. While the public focus remains on GPU shortages, the actual constraint for AI is industrial electricity. Connecting a facility this size to the regional grid takes years of regulatory approval. By building their own fossil fuel plant, Amazon avoids the public utility grid entirely. And avoiding that grid reveals the true bottleneck in the AI race. Bypassing the queue. The Texas grid operator currently has hundreds of gigawatts of interconnection requests stalled in a massive backlog. A data center without power is just a stranded asset. By running off-grid, Amazon skips the regulatory line entirely. They are trading massive upfront capital for speed. But this raw speed requires a severe carbon trade-off. The carbon reality. The state permit for GW Ranch authorizes up to 33 million tons of carbon dioxide emissions annually. At capacity, this single private power plant will output more greenhouse gas than the largest coal facility in the United States. Defenders argue this off-grid model spares residential customers from rate hikes and grid instability. But the actual capital allocation tells a different story about corporate priorities. When forced to choose between scaling AI infrastructure and meeting their 2040 net zero targets, the balance sheet chose natural gas. The sheer scale of this footprint breaks the illusion that AI growth runs purely on renewable credits. And the financial consequence of this carbon reality changes the entire business model. The real implication. The decision to bypass the Texas grid and accept a massive fossil fuel permit points to a permanent sector realignment. Big tech companies are rapidly transforming into heavy industrial energy producers. By internalizing power generation at GW Ranch, Amazon is explicitly tying the future of cloud compute to raw thermodynamics and fossil fuels. For investors and industry operators, this means the fundamental margin structure of the tech sector is undergoing a massive shift. You are no longer just modeling the depreciation of server racks and cooling fans. You are now forced to model the maintenance, fuel supply chains, and regulatory liabilities of private utility networks. The operating costs for foundation models will inevitably reflect these sprawling industrial capital expenditures, crushing the software-like margins the industry is used to. Watch the upcoming Q4 capital expenditure reports to see exactly how hyperscalers reclassify this off-grid power spend. Subscribe for more.